Alright, this is me testing my voice to make sure that it's working properly. Because apparently my voice was sounding kind of weird. Let's see. Still have the echo, but alright. It stopped now? You sure? I just tested on my laptop. Yeah, I'm just iron out these technical difficulties before I sound ridiculously annoying. Alright, so we should be good there now. Okay, cool. Alright, when in doubt, restart. Alright, share this link in the Discord there. And let's get the show on the road. I was on, right, so we had the last, I'll do 15 more questions for all. Unit 1, ComSci, jump to 10. Yeah. Alright, so we good? All inside there? Triple I've seen 3 people. So we're not dealing with 2018 people. Which 2018 people are you talking about? Right now I'm doing keep multiple choice, keep ComSci unit 1 multiple choice question. ComSci unit 1. No, I don't do whole papers like do answers to the whole papers. No, I just have sample questions that will show you basically what you're going to see when you do the questions. Because trust me, once you see certain types of questions, it's gonna be like that all the time, consistently. So once you can do the questions that I pick out here, you should be okay, so don't worry too much. Alright, so I'll do 15 questions every Sunday night. Well, this is the last set of 15 I'm doing for ComSci. I'm switching to IT next week. Because once you have three once you have these 3 videos, you will have most of the ComSci questions that you will see, and they should be able to figure it out after that. But when it comes closer to the exam, I'll make up some more questions that will challenge you more. Alright, so let me start with this one. Listen. In the programming language C, what data type should be used to store currency value in our program? That shouldn't be too high on the intellectual ladder there. I trust you know that. Right, so so basically what they're telling you is you have to choose your data type, and your data type is double, which is B, because double will give you decimal places, so you get like 30.45, right? Because our currency value, so you want to get the currency. Alright, nothing too hard there, nothing too hard there. Let's move on. This is 1. We're now 2. Alright, to execute a program in a high level language, it must be translated to this one, a little tricky. Right, so the answer is D. Right, because for a program to be executed, you can't execute something that's now ones and zeros. Because when you fetch execute cycle, all the computer is going to get is the ones and zeros that you get, so that's machine code. It can't execute anything else. A computer can't do anything other than ones and zeros. So you just kind of had to accept that. Alright, cool. We had to get down to the lowest common denominator, or the lowest possible thing our computer can understand, which is ones and zeros. That's why you learn all that stuff about logic gates and multiplexers and registers and flip-flops and all them things, because you had to get it down to ones and zeros in order for it to be able to be executed. Assembly language will be using like mnemonics like add, jump, and all that stuff. The assembly language one, you can get down to assembly language and still transfer it to another computer or something. So source code is what you type. Object code is getting it down to object code. Most of the times get it down to assembly language, but it still has to do something called linking. So object code is not object code is a close answer, but it's not the answer. Machine language is a way better answer than object code, right? Right, so let's look at the next one now. 3. So let's try that one now. So you have an algorithm, and now we have to determine what the value of the variable sum when the for loop terminates. So work it through and let me see what you'll get. Think hard, think hard. Alright, apparently it's taken long. Is your brain hitting you? The if statement, yeah, it has some tricks in it. Alright, so we have an array with 5 numbers. We have 1 and 9, no, 6 numbers, 5 numbers, yeah, 1, 9, 8, 2, and 11, right? It says int x is equal to num location 0, so that means x is equal to number 1, right? Because that's the number at that location. Right, so we deal with this line, we deal with that line. Next line now, we have an int r has nothing in it, we don't know what it is, and we have sum is equal to 0. Okay, cool. Then we now know that r starts off as 0 and we're trying to get to 5, so r going from 0 to 4, which is basically 5 times, right? So we know this loop is going to run 5 times. What is going to happen 5 times? If num r, right, so num location 0, which is the first number, so it'll be 1 mod 2 is equal to 0. If 1 mod 2 is equal to 0, and the number in location 0 is less than x, so that would be and 1 is less than 1. Right, that's what this statement here. If num mod 2 is equal to 0, which is 1 mod 2, because we know num r is 1, and we know that from there, right? And 1 is less than 1, then we'll find the sum of the numbers, right? But because 1 mod 2 is not equal to 0, therefore, and 1 is not less than 1, therefore the first thing that we're going to do, we're not going to add anything. Nothing is going to add up into sum, so sum will stay at 0. Sum is equal to 0 still, right? So that's the first loop. Second, now we're dealing with num location 1, right? So num location 1 is what we're comparing. Oh, you don't know what mod is? Mod is you're gonna divide and it'll give you the remainder. So like if you have 3 mod 2 is equal to 1 remainder 1, the answer of the mod is 1. Right? So you always have to check what the remainder is, not what the answer is. So you ignore the answer and you're just checking to see how much the remainder is, right? So 1 mod 2 is not equal to 0. That's it. Mod is like an easy way of finding even numbers. Right. So now our question is looking at location 1 says 9 mod 2 equal to 0 and 9 have to be less than 1. Because the value of r the value of x is going to be 1 all the time, that never changing. Oh no, x changing to num r, so my bad, sorry. So x is still going to be, this is still going to be the 1, right? Because r would be 0, r never went up yet. Yeah, r only goes up when we reach here, good. So 9 will be less than 1. No problem there, so then the sum is still going to be 0 because both of these need to be true. 9 is not less than 1 thing. However, when we reach to this point here, this is going to be num 1. So the value of x is going to change now from 1, and x is now going to change to 9 because 9 is the next number here. Everybody following what's going on there so far? Right. So now the value of x changed to 9, so now we could go on to the third loop. Third. Right, so the third loop now is going to now be comparing norm location 2, which is going to be the 8. So it's going to be 8 mod 2 has to be equal to 0. 8 mod 2 is equal to 0, good. So we have a potential here because this is correct. So this is correct. Then the next one now, we have to check now to see if 8 is less than the new value of x, and the new value of x is 9. So 8 is less than 9. So that means both conditions are correct. Because both conditions are correct, now we're going to be able to do the addition parts that we kind of duck in for a while now. So now we could add the value inside R, which is 8 plus sum. So sum is equal to sum plus 8. So now sum is equal to 8. Alright, so you're following me there so far. Going on now to the fourth loop. Fourth loop now is going to become now R becomes location 3. Before we did that, we're gonna have to take the 8 and put it inside here. So that x gonna now change to 8. Because this line here is always going to take the last number we was looking at, which would be 8. So this was our location 2, so now the x changes to 8, right? So now we're gonna compare to see if num location 3, which is now 2 mod 2, is that equal to 0? Yes, it is. So we take off that part of the condition. Now we have to check the next one, which is the AND part. And then we have to check the new number they have, which is 2. Is 2 less than 8? Because x has changed to 8 from the previous number. So it's 2 less than 8, good. So now both of them are correct. Because both of them are correct, now we're going to have to do the sum is equal to sum plus num. So sum was last seen at 8. So now we're going to have 8 plus 2, which is now going to carry us sum is equal to 10. Right? And now the value of x here is going to end up changing to 2. X is equal to 2 now, because we always take the last value that we had. Go back up to the loop now. Now we're going to have the fifth time. In the fifth loop now, we're going to have 11 mod 2 is equal to 0. And 11 mod 2 is not equal to 0, so we just don't bother to consider that. So even if we have the and we could check to see if 11 is less than 2, it didn't fit in that criteria either. So the last time we had summers was 10. So that's why the answer is going to be C. Alright, any concerns? Not too sure? Does that make sense to you? The real key is understanding when this if is going to happen, because the if has to have two conditions met in order for it to work. It needs to meet this condition, and it also needs to meet this condition. So if you could check mod, basically what it's looking for is just even numbers. So checking to see if you have an even number and the previous number that I had is less than the Sorry, the new number you have is less than the previous number, so that is the 9 less than the 1, is the 8 less than the 9, is the 2 less than the 8, is the 11 less than the 2. That's what happening each time you was checking the previous number. And then you just determine which one is which. Okay. Liron, message me on Instagram when we done, and I'll send you some videos that will that might help you through your theory issues. Alright, so the next question now is to take this same algorithm, and now we're going to try to apply this stitch. Alright, so we're taking the same algorithm and now change the if condition in line 5 to num r mod 1. So basically we're looking at odd numbers and you're checking to see if the number is greater than x after. So we do the same thing, it's just that you're looking at mod 1 now. Tell me what the answer will be. If you understood what I did before, then you should be able to work this out. Take your time, take your time. Don't rush it. On est au Claudia. Man, see, you forgot this. Alright, let's work it out again. Alright, we're starting off with an integer called x. I'll do it in a different way this time, a little more streamlined. So we have our x. We have a r. We have a sum. And yeah, so basically we're going like this. X starting off at 1, R starting off at 0, and sum starting off at 0. We know that, right? So, if we deal with this for loop, R starts at 0, cool problem. So that means we're dealing with if num location 0 is equal to 0 and num location 0 is less than x. So let me tell you what, num r is going to start off at 1. So here's our question. Is 1 mod 2? So the question we're asking is 1 mod 2, is that equal to 0? The answer is no, because it's odd. But they told us to replace it with num r mod 2 is equal to 1. So we taking this line here and we're replacing it with that there. So what we really have is 1 here, and instead of num r less than x, we have num r greater than x. So our question is 1 mod 1 equal to 0? Yes. No. Is there a remainder? So sorry, num mod 2, my bad. No, represented 1 here. So it's num r mod 2 is equal to 1. Right, sorry, yeah. Good. So it's 1 mod 2 equal to 1. Do we get a remainder? Yes, we do. Because 1 mod 2 will have a 1. So that means this is true. And is num r, which is our 1. So is 1 greater than 1? No, it's not. 1 is not greater than 1, so therefore there is no addition that's going to take place here. Cool. So now we take the loop back up. No, sorry, then we set x is equal to num r. So x is equal to 1 again, right? Because r never went up. So we're just dealing with that as a 0. Good so far? Alright, so this here is going to be location 0 still. It never went up. Alright, good. So x is 1, right? So now we go back up to our loop, and r is going to change to 2. So sorry, r is going to change to 1. So now we're dealing with r. Num r is location 1, right? What is that location 1? Is the number 9. So we're dealing with the number 9. Is 9 mod 2? Do you get a remainder of 1? Yes. Tick, tick. Sorry, so we do get a 1. And then it's going to ask, is num r, which is 9, is 9 greater than 1? Because x is 1. The answer is yes, because we know num r is 9. So 9 is greater than 1. Yes, so therefore we're going to find the sum. We're going to say the sum of the current value of sum plus num r, which is going to be 9. You grasp that there? Any problems with that there? Because that's the tipping point there. If you grasp that, then we should be able to blaze with the rest. Well, yeah, you're jumping the gun. I'm just making sure you understand. Right, so now we go in and do this line here, which is x is equal to num location 1. What is that num location 1? The number 9. So x is going to change to 9. Then we're going to ask our question now. Now we're going to be looking at number 8. So num r is really 8. So we're going to check to see 8 mod 2, is it equal to 1? Nope. 8 mod 2 going to be 8 mod 1, sorry. 8 mod 2, is 8 mod 2 equal to 1? The answer is no. So therefore we're not going to add anything, because once one of these conditions wrong, the whole thing wrong. The whole thing will collapse, and therefore we won't do this. So once the whole thing collapses, then we now have to just continue and change this to num location 2. So what is that num location 2? The number 8. So x gonna change to 8. The new value that we get now for num r gonna be 2. The r changing to here, and then the r will change to 3 eventually. The sum will stay at 9, and then not changing anything. Good, so from this to now, we're going to check to see if the new number that we get for num r is 2 mod 2. Is it equal to 1? Nope. So therefore, we're not going to do anything, because once one condition is wrong here, we don't even bother to try to do the addition part. But we have to do this next part here, which is change the r to, this is location 3. Alright, so 3 here, what is that num location 3? 0, 1, 2, 3, 2. Alright, so x is going to change to 2, and our new num r is going to become 11. So then we're checking to see if 11 mod 2 is equal to 1. Yes, that's a remainder. Good, that's true. So we get something that's true finally, which is this. And then now we have to check to see if num r, which is 11, is 11 greater than 2. 11 is greater than 2. Yes, good. So now that 11 is greater than 2, we're going to take the instructions of this line now, which is take the 11 and add it to the previous value. Add to 9. 11 plus 9 is going to give you 20. And by now, our value of r has reached 4. So that means it's only going to go 4 times, because the for loop is 0 to r minus 5, which is 4. So the last value of sum that we will have will be 20. Therefore, your answer is D. What's that? Imagine you write up your code in one night without errors and you don't know what mod means. Yeah, that would be a problem. Not knowing what mod is at this stage in life, that's a little bit on the scary side. Alright, anybody have any questions about that? so that let me press. Alright, let me hear. Which of the following allows already compiled modules to be combined with the compiled program to generate an executable file? Answer here is B, the linker. Because let me see if I could break it down for you. Source code, object code, exe. In between here, you have the linker. In between here, you have the compiler. So in order for the source code to get the object code, you gotta compile or interpret, however. And then in order to get from the object code to exe, you need to get to the linker. Next one, Mautic. Provided you know your theory. If you don't know your theory, these questions will be like, what? Right, the function of a programming paradigm is to do what? Alright, so you have two close ones. You have either D or B, but really and truly, it be a programming paradigm is a way of viewing solving a problem. It don't really change how you see a program. Both of them kind of weird. This one has C's, this one has view. But view is a more technical term than C's. It's basically how you view it. Okay, next one. Which are the following criteria? I'm here. Which of the following criteria should be considered when choosing a suitable programming language? Let's see. Right, when choosing a suitable programming language, you should consider the nature of the application, because the programming language that you use will basically, if you want to program for the web, you need a particular programming language or something like that. Availability of a compiler or interpreter, yeah, if you're on a computer that don't have that particular compiler or interpreter, you kind of, it makes no sense you write the program. The expertise of the program, yep, if you choose a programming language where the programmers don't know what to do or don't know how to code in it, then you'll have a problem. So you're going to need to consider all three of them. So the answer would be D, right? because it would be kind of unfortunate if you if you give somebody to program in Fortran and nobody know how to program in Fortran except for like programmers from the 1970s. Or you do a Python application and then none of the people can program in Python. That would be very awkward. Alright, so let me see our code question here, boy. Code, we talking about a structure. Alright, let's see. Two variables are then declared as follows, right? So we have two structures, record 1 and record 2. Remember, record 1 and record 2, they both have an integer x and an integer y, well, array inside it, right? The two following segments will result in record 2 being an identical copy of the other. So basically, when you have structures, you can simply just say record 1 equal record 2, and we'll just take what's inside record 1 and throw it inside what's inside record 2. Because with structures, you could copy directly. You don't have to copy each location inside the structure. So the answer is B, right? The reason why C wouldn't work is because Y is not one variable, Y is an array. So for C to be able to work, you would have record 2 dot Y0 is equal to record 1 dot Y, record 1 dot, oh damn pen, just so. Yeah, record 1 dot Y0, then record 2 dot Y1 is equal to record 1 dot Y1, and that would have been going down the line there. So that would work out too well. So the only way to do it is to literally just copy the whole thing. Just put the name of the structure and copy it in. Alright, everybody understand that? on to the next one now. Alright, what is the correct order of the compilation process? Alright, so by process of elimination, syntax analysis is always do first. Is all the lexical analysis first. So after you do the lexical analysis, then you'll do the syntax analysis. So we have 5-1. Because you can't do syntax analysis and then immediate code generation. That would make no sense. So already C is the forerunner. Then you go to 3, semantic analysis. After semantics, you do intermediate code generation. After intermediate code generation, you do code optimization. After code optimization, you have code generation. So the answer here is C. So if you got that, you're correct. I'll let you go now to number 40, this number. Next up, kids, is this. Ooh, an X trace table, but this one shouldn't be that hard to do. Come on, you can do it. Alright, so they trace this out. Alright, x is 2, we have a x, we have a n. X is 2, n is 3 when we start off. And we have while n is greater than 0. Is n greater than 0? Yes, it's 3. X is equal to x plus x by 3. So 2 3s are 6. N is equal to n minus 1, n changes to 2. Cool, we back up. Is n greater than 0? Yes, 2 is greater than 0, so x is equal to x by 3, that's 6 by 3, 6 3s are 18. N goes down by 1, because of the n is equal to n minus 1, so that'll go down to 1. Is 1 greater than 0? Yes, it is. So therefore we look back up again, and then we're going to say 18 by 3, which is 54, and then n is equal to n minus 1, so we get 0. Now we look back up, 0 is not greater than 0, so therefore that'll be the end of the loop, so 54 is our answer. I advance, forward. Alright, which of the following is the best paradigm to use for calculating total usage time over all internet accounts on a server? Best paradigm to use. Alright, this one is a tough one because anytime you're calculating something, by default, you're supposed to think procedural, right? But they say total usage time for internet accounts on a server. Now, when you're writing programs for a server, you're trying to write the programs in the lightest way possible. And the lightest way to write a program is to do a script, because scripts are pre-compiled. You don't have to keep compiling it every single time the program runs. So scripting is basically the answer, but procedural is, it will basically be a procedural paradigm. Now the question is scripting a paradigm? That's one of the things that kind of gray in the syllabus. So I kind of lean towards C, but I understand that A is most likely going to be the answer because it's on a server. But then the question is, scripting is not listed as one of the one of the paradigms in the syllabus. In the syllabus, the paradigms are functional, procedural, object-oriented, and declarative. So, because it says best paradigm, I usually give C as the answer. Because scripting is not a paradigm. But it could be considered. According to the syllabus, they have aspect and scripting separate from the 4 paradigms. So this question is a tricky one. Based on the fact that it's asking for the best paradigm, I will stick with procedural, because procedural does calculating very well. Calculating stuff is literally what procedural is made to do. Step by step by step by step by step by step by step. Yeah, that's procedural kind of bread and butter there. But because it's on a server, scripting might be acceptable too. So I can't give you a definite answer, but I would go with C for sure. Maybe if I get some more light on it sometime when I'm talking to another human being. Alright, so let's do this one now. What's the main reason for the difference in programming languages for small mobile devices like mobile phones and desktop computers? Programming languages for small mobile devices and desktop computers. The main difference is basically that when you're programming for a computer, you have plenty of resources now. But when you're on a mobile device, you have less memory and other resources than a desktop computer. So the answer is C. Alright, it's definitely not because they use more. It's definitely not because they have better programs. It's definitely not because they have a larger screen. So by processor elimination, it's clearly C. Right. Alright, we're on the home stretch here. Alright, codes to the user wishes to declare variable C to store the square root of an integer, which is the most appropriate place to store a square root. It would be double. Yeah, double. Because a square root could give you a decimal. So let's say I had the square root of 25. That'll be 5. Cool. If we had square root of 26, it'll be 5 point something 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 5.00001 or some kind of thing like that. So what you want to do is you need to be able to hold the decimal value, which is why I need to be using a double. Alright, last two data types now. Sorry, last two questions. Alright, a text file data.txt contains several lines of data. Program opens the file as open data.txt in write mode. Which of the following best describes what is happening here? ICB. Right, so it's opening a file, data.txt, W means in write mode. Write mode basically goes into a file, clears out whatever is there, and starts to write from the top each time. So every time you open up the file, it will clear out whatever it had before, and be like, hey, I'm coming to write to this file, therefore it'll write everything from the top. Right? So write mode will existing data is completely erased and it will contain only new data. Right, so write mode will clear everything from the top, right? A mode, which is append, is going to add, and RW is going to give it the ability to read and write to one file. Usually you will just read stuff from the file and then you could write it to and then read back again, depending on what you need to do. So write mode is going to clear out all the data. I see some of y'all said B, but new data being stored at the beginning of the file. That will be W plus, I think. There is write plus. Don't quote on that. Alright, last one now. An integer variable x has a certain value which the following statements can be used to store the value of x in the file. So to print a file, you have to use fprintf, and then you have to use %d and x. This is an integer, so that means they'll use %d. But in order to print to the file, you have to say the state name of the file, so the answer will be b. If you don't put the name of the file, then it wouldn't know what to print it. So that's why you have to do b. This part here is the most important part, file. That's the name of the file. Here you'll get a syntax error easily because you're using fprintf, but you didn't state the file to use. The fprintf here will be looking for what file to print it to. So that's why the answer will be B. Right, so that's the last one there. This video will be added to the ComSci playlist, so you will see that there. And to have two other videos before this with 15 other questions, and basically once you go through the questions in the 3 videos, which will be 3 videos in this playlist, so let's look back for this playlist. You would have seen, like, I don't know, probably about 90% of the types of questions that they will have. That should prepare you for answering the questions. Right, if you have any questions, you could always message me on Instagram, and I will try to facilitate you. But videos in this playlist, ComSci multiple choice, unit 1, should cover most of what you would see. Alright, cool. Alright, you're welcome, guys. Thank you very much. Have a good night. I'll be back next week, but next week I'll be doing IT past papers, so you can let IT students know. Who didn't keep Unit 1 IT, I'll be dealing with Unit 1 IT next week. Alright. You're welcome. You're welcome. You're welcome.